Hi everyone, welcome back to another day of notes. Today we're going to deal with, we're going to do day 4. Oh, something? Google popped up. We're going to do day 4, which is all about factoring trinomials, and we're going to add a little bit extra. We're going to also factor polynomials, so with 4 terms as well. Okay, just a quick review. We need to factor this binomial. When we have a binomial, we're going to do a GCF factoring. Okay? So that's what we're going to basically look for. Is there a GCF that we can take out? So what we're going to do is we're going to go term by term. So if I look at each term, I've got a 2x squared and a 4x, or a negative 4x. First thing I'm going to look at is the number. Okay? Ooh, not that. Ignore that. What can I divide both 2 and negative 4 by? And when I ask that question, I'm looking for the highest number I can divide them both by. Well, the biggest number that I can divide them both by is 2. Okay? So that's part of my GCF. Then I look at the variables. I have an x squared and I have an x. Okay? Well, what are the most, how many, I can never figure out how to ask this question. What are the most x's that I can take out? That's not the right way. Okay? How many x's can I take out from each of them evenly? Well, they both have at least one x, so I can take out a single x. Okay? So 2x is my GCF, but I'm not done factoring because now I need to write the leftovers. So I'm going to divide each term by the GCF. Okay, so 2x squared, well, 2 divided by 2 is just 1. X squared divided by x, I had 2, I took 1 out, so I'm left with a single x. Negative 4 divided by 2 gives me negative 2. I had 1x, I took it out, so I don't have any x's left, so I'm left with negative 2. So this is my factored form with the GCF and the leftovers. And that would be my final answer. Okay? Now, to factor a trinomial, just a reminder, trinomials tend to look like this, where you have some term with an x squared or variable squared, followed by a term with just a variable, followed by a constant at the end. Okay? So we usually say that this first coefficient is a, second coefficient is b, and the last one is c. Okay? It's kind of important. Step 1, factor out the GCF if it's possible. It might not be sometimes, so we don't take anything out. Step 2, we use the box method. Okay? So not only did we use box method for multiplying, we're going to use it to undo the multiplication and factor as well. Okay? So these next 6 steps, seems like a lot, it's really not. I'm a poet and didn't know it. Okay, enough with being corny. So, my dog just sighed. I think, like, he basically rolled his eyes at me. It seems like a lot of steps. It's not really. And it's kind of wordy. It's kind of hard to understand. So, right now, just write down the steps so you have it as a reminder later on, and then I'll walk you through the steps and the problem. Okay? So, step 1, when we have our box, we're going to fill in the first and last term into the box. Okay? Then we're going to multiply the a times the c. So a meaning this first coefficient and c meaning the last coefficient. Okay? And we're going to make a factor table. So we're going to find all the factors that make that product of a times c. Okay? Then we're going to find 2 factors from that factor table that also add up to b. So that's that middle coefficient. Using those 2 factors, we're going to fill in the remaining squares. Okay? Then we're going to find the GCF for each row and column, so that way we can write something on top of the box and on the side of the box. And finally, we'll write out our 2 binomials. Now, if you already had 4 terms because you have a polynomial, you're just going to go ahead and fill in those 4 terms into the box, and you just go ahead and repeat. You just do steps 5 and 6. Okay? So let's look at an example. We have 2x squared minus 9x minus 35. So the very first question we want to ask, is there a GCF? Okay? Is there something that I can divide all 3 terms by? Well, if I look at the numbers, I have a 2, a 9, and a 35. Nothing. I can't divide that by anything. Okay? And if I look at the variables, I have x's here and x's here, but not on the last one. So because I couldn't find anything that would work, I have no GCF, which is fine, okay? The next step I'm going to do is go ahead and make my box, okay? And I'm going to take my first term, the 2x squared, and I'm going to put it in the first box. I'm going to take my last term, the negative 35, and put it in the last box. Now I just need to fill in these two missing ones. So this is where I'm going to multiply my a times c. And a is 2, b is negative 9, and c is negative 35. So that's what I multiplied together, 2 and negative 35, and it equals negative 70. Now I'm going to go ahead and make a factor table. So I'm basically going to find factors of negative 70, and I'm also going to test to see if they add up to my b term, the negative 9. Okay? So, because it's a negative, I know that when I multiply two numbers together to get negative 70, one has to be negative. So that's, my negatives are going to go here. So I'm going to do negative 1 times 70. Okay, that's my first factor. I'm going to add it together. It's 69. It's not what I need it to be. It's not the negative 9. So I move on. So the next one, I can divide it by 2. So I'll do negative 2. Do that division, I get 35. So these are my two factors. Do they add up to negative 9? No. So moving on. The next one would be negative 5 and 14. Do they add up to negative 9? No. They add up to 9. I need it to be negative 9. So I gotta keep going. Now, if you're not sure what numbers to try, what I tend to do is just go ahead and plug it in the calculator and just start dividing by numbers. And if it comes out to be a whole number, those are factors then. Okay? So next I'm going to try negative 7. Divide that. I get 10. Add them together. It gives me 3, not negative 9. Moving on. So now I'm going to try negative 10. Negative 10 divided by negative 7, or 70 divided by negative 10 gives me 7. That gives me negative 3. So I am getting closer, which is helpful. Okay. Oop. You sneak peek, you found it now. Now I'm going to try negative 14. Divide that. I get positive 5. Add them together, and I get negative 9. So I found two factors that multiply up to a and c, a times c, negative 70, but also add up to b, negative 9. So now I'm going to take these two numbers, and I'm going to fill in these missing boxes. But I'm going to fill them in with just a single x with them as well. So negative 14x and 5x. Okay? So now that I have those, I've got a lot of things happening over here. Okay? Now I'm basically going to go and just try to find the GCF to put on top and on the sides for each one. So the first thing I'm going to do is look at these two. What's the GCF of 2x squared and 5x? Well, what do they have in common? Can I divide 2 and 5 by anything? No. They both have an x, so that's my GCF, and I write that at the top. Then I look at the next group. Okay, negative 14x and negative 35. Well, I can divide them both by negative 7. And this guy is the only one with an x, so negative 7 is my GCF. Okay? And that's actually my first binomial. Then I'm going to go across as well. So I got negative 2x squared and negative 14x. Well, they are both divisible by 2, and they both have an x to give. So 2x is my GCF. Okay? Then I look at the last one, the last group. Ooh, I got 5x and negative 35. They are both divisible by 5, and that's about it because they don't both have variables. Okay? So now that I filled in the outside of the box, I have my two binomials. 2x plus 5 and x minus 7. So I go ahead and write out my answer. And it doesn't matter the order you write it in, but you do need to write out both binomials. This is the factored form because this is what got multiplied together to create this. And that's what we're trying to find. Okay? Moving on, you guys are going to try this one on your own. Okay? Example 2, we have 4 terms. So because we already have 4 terms, we have enough terms to fill in the box. Okay? But before that, I'm going to ask myself, is there a GCF? Can I divide 10, 6, 5, and 3 by something? No, I can't. Well, this has 3 x's, this has 2, this has 1, but this guy doesn't have any, so I can't pull out an x, so there's no GCF. Okay? Now, because they already have, I already have 4 terms, I don't need to worry about multiplying a times c or any of that nonsense. I can just go ahead and fill in my terms. So I've got 10x cubed, 6x squared, 5x, and 3. Okay, and I tend to just go across the line, and it's easier to fill in that way. Okay, so now I can go ahead and find my GCF. So I'm going to look at this first group, 10x cubed and 5x. They are both divisible by 5, and they both have 1x to pull out. So I pull out the 5x, and that's the GCF. Over here, I've got 6x squared and a 3. They're both divisible by 3. So that's my GCF. Then I do it again. Up here, 10x cubed and 6x squared. I can divide them both by, what is it called? 2. And I also have 2 x's that I can pull out here. So 2x squared is my GCF. And then 5x and 3, well, there's nothing I can divide both 5 and 3 by other than 1. And I can't pull out an x from both of them. So 1 is my greatest common factor. Okay? So when it doesn't look like anything works, 1 will always work. Okay? So now that I have my 2 sides filled in, I can write out my binomials. So I have 5x plus 3 and 2x squared plus 1. Okay? And now you guys will try this one on your own. All right. Example 3. Hopefully we have a little bit of the hang of it. First thing I'm going to do is ask. First I'm going to read directions. I need to factor this. So I need to ask, is there a GCF? Can I divide them all by something? No, not really. So no. Okay? So now I'm going to go ahead and start the next step, which is identifying A, B, and C. So here, A, remember that's the coefficient in the front. So if you don't see it, it's really a 1. So that's my A, -7 is my B, and 5 is my C. So I need to find something that multiplies up to A times C, but adds to -B. So I'm going to do A times C, 1 times 5 gives me 5. And I'm going to write out the factors. So I've got 1 and 5 I can multiply together to create that, but that adds up to 6, not -7. Then I can do -5 and -1, the negatives of them, because they'll multiply up to be a +5. But if I add those together, I get -6, not -7. And that's really it that works for 5. Okay? So if you can't find anything and you've tried all the factors and nothing works, what this means is that it's prime, like it's not factorable. We couldn't do anything. So when that happens, we just write the problem again. Okay? It's already factored. All right? That's what we can do to it. Okay? So, and I forgot that I should have filled in the boxes, but I couldn't fill anything else in, so that's how I know I should just leave it the way it is. Okay? And when that happens, when we can't factor something at all, that's called a prime polynomial. And that means it can't be factored with the box method, like we saw, but it also doesn't have a GCF at all. So there's no kind of factoring going on. We're not doing GCF factoring or box method. Okay? That's when it's prime. You can't do anything to it. Now, just keep in mind, when we are factoring, when we actually do get to factor something, our final numbers that we get should be prime, meaning they can't go anymore. Okay? So, here's how we can check to make sure everything's prime. All right? So, example 4, we have to factor these, and these are special cases. Okay? Very, very special cases. All right? Same thing, same steps I'm going to take. First thing I'm going to ask, is there a GCF? So I've got x squared minus 9. So no, they don't even have a common number or variable. Okay? Now what's weird about this is that this is a binomial, but it's also a quadratic. It's got a degree of 2. Okay? So it kind of looks like the trinomial, but it's missing that middle term. When you have a degree of 2, just make it into that trinomial. So because I'm missing the middle term here, I'm just going to go ahead and put that middle term of being 0. Spread it out. So that way I have my a, which is 1. I now have my b term. Remember, b is always with the x. And -9 is my c term. Now I can go ahead and try to factor by the box method. So I'm going to do a times c, okay, which is going to give me -9. And I'm going to go ahead and find the factors. So I got -1 times 9. Remember, pick negative numbers to start with. And that will add up to be 8, so not 0 like I need. The next thing I can try is -3 and 3. That'll multiply up to be -9. And it adds up to be 0. So those are the two factors. So now I can fill in my box. Okay. Oop, shouldn't have shown you that yet. Oh well, you'll figure it out. So my first term goes in the top one, the x squared. The last term, the -9, goes in the bottom one. And now I've got two new terms, -3x and +3x. Okay, so now I'm going to find my GCFs. So I'll start with the one I've already shown you. -3x and -9 are both divisible by -3, and that's it. X squared and 3x, well, I can take out an x from both of them. So that's the GCF. X squared and -3x, I can take out an x from both of them. And 3x and -9, I can divide them both by 3. So I've got my factored form. I got my factors here. I just need to write them as binomials. So I get x minus 3 times x plus 3. And I don't know if you guys know this, but this is one of the special cases we showed you on day 3, where if you have the sum or difference. Okay, so like one subtraction, one's addition, but everything else is the same. When you multiply it together, it gets you that. So you might be able to recognize it from there. Okay? But if you're missing that middle term, just put a 0 in the middle and work it out. Okay? The next one. So the first thing I need to do is ask, is there a GCF? Can I divide them all by something? Well, I've got 2, 4, -18, and -36. I can divide them all by 2. So yes, there's a GCF, and if there is, I should pull it out. I can divide them all by 2. That's really all I can take out, though, because they don't all have x's. So I went ahead and took out the 2, and I wrote what was left over. X to the third plus 2x squared minus 9x minus 18. Okay? I'm not quite done yet because this is still very long, and this, because it's 4 terms, I might be able to factor further. So I'm going to take those 4 terms, and I'm going to do the box method for it to see if I can factor it anymore. Okay? So I already have 4 terms, so I'm going to just fill in the box. If I can get just a box to show up. First term, x cubed. Second is 2x squared. Then -9x and -18. Now I can do GCF. Okay? So x cubed and -9x, I can take out an x. 2x squared and -18, I can divide them both by 2. Okay? X cubed and 2x squared, well, they both have 2 x's to give, so I can take out x squared. And -9x minus 18, I can divide them both by -9, and that's my GCF. So now I can write it out. Now when I do this, I don't want to forget about my GCF up front, okay? So I get the 2 times these two binomials, x plus 2 and x squared minus 9. Now, x squared minus 9, because of that degree there, that should be a red flag popping up, okay? That I could probably do more with that. So, that one is actually not prime. we can still factor it. In fact, that's the same problem from part A right here, which we have already factored. So I'm not going to do all the work over again, because you guys can see it here, but we basically have to do all this for it as well. We need to keep going with the factored. But I know that x squared minus 9 is really x minus 3 times x plus 3. So I'm going to rewrite it. So I've got 2 as a factor, x plus 2 as a factor, and all this as factors. So this is my fully factored form. This is a really rough one, guys. Okay? This is the fully factored form because each one is prime. I can't factor them anymore. Okay? So now you guys are going to try this one on your own. Give it a try. If you have any questions, then we could talk about it in class. Other than that, I will see you next time. Have a great day. Bye.